All right, so the last thing I want to take a look at here with the anatomy of the heart is a little bit about the valves before we move on to a little bit more how the heart actually goes about working and some of the components of that. What we're going to see is there's really two main sets of valves within the heart. You have your atrioventricular valves and your semilunar valves. We're going to see a lot of these have multiple names. So, like the right AV valve is known as, well, sometimes you can say the right atrioventricular valve. It's also the tricuspid valve. It has three cusps, hence the name. Where the left AV valve is known as the mitral valve, as well as the bicuspid valve, because it has two cusps, two main cusps. We can see that these two valves are the ones that would have chordae tendineae connected to them, which are connected to papillary muscles, where the semilunar valves get their name because they look like a half a moon. And we're going to see that there's two of those. The right side semilunar valve is the pulmonary valve or pulmonic valve. It is separating the right ventricle from the pulmonary trunk, where the aortic valve is separating the left ventricle from the aorta. And again, you should know all the names of these. So the right AV valve, know it as the tricuspid. Left AV valve, know it as the bicuspid, as well as the mitral. You should know all the names to these ones. They all get used pretty much interchangeably. What we're going to see is when these are open, the cusps are going down into the ventricle, allowing blood to travel in there. And when the ventricles contract, as that pressure builds up, it slams that AV valve closed. The chordae tendineae are really connected to this, so as that valve slams closed, it holds onto them so it doesn't blow back the other way. And it keeps it from being pushed open back into the atria. So you can kind of see it on these ones right here. When it's open, blood is flowing through. You can see the chordae tendineae attached to this is keeping the blood from traveling back through the other direction on those. And you can kind of see the two different AV valves, the tricuspid as well as the bicuspid, the chordae tendineae attached to those, and you can even see a papillary muscle in an actual dissection look right here. And again, you can see each of the images of these ones. You can go back through and look at these a little bit more if you want to on the actual PowerPoint. The semilunar valves, like I said, get their name because they look like half moons. The one thing I would say about these ones is they are not nearly as much. It's really the backflow of blood, the kind of recoil or gravity pulling against that is really causing these semilunar valves to close. Because of that, they don't need as much protection against backflow. Therefore, there's no chordae tendineae or papillary muscle at all. It's just blood going back against those that is going to slam these shut. The pulmonary semilunar valve, like I said, is between the right ventricle and the pulmonary trunk, where the aortic is between the left ventricle and the aorta. And again, they have these three little kind of half moons that make a little pocket. And again, no papillary muscle, no chordae tendineae. When the ventricle is contracting and there's enough pressure, it is pushing these valves open, and blood is traveling through there into the main arterial trunks, the pulmonary trunk, as well as the aorta. As the ventricles start to go to relax, that pressure is going to drop. The flow of blood is going to drop back in. This is due to gravity, and it is going to cause these to close, and that is keeping the blood from flowing from there back into the ventricle. And you can kind of see these pushing the blood, pushing it out, and you can see the little cup to it that I said right there. And these ones, there's generally three kind of half moon cusps that make up each of these valves. And you can see on these ones right here, semilunar valves on these two. You can see the pulmonary semilunar valve going to the pulmonary trunk, the aortic semilunar valve going to the aorta. And this is a neat view that kind of shows you this in this fibrous skeleton. Again, all the muscle on the ventricles is separated from the muscle on the atria. We'll get into why that is. But this fibrous skeleton, this is kind of an oblique section through the heart. You can see all these right here. So you can see the tricuspid with the three cusps, the bicuspid with the two main cusps here. The other thing you can see on this is the presence of, on those semilunar valves, of those three half moon-shaped cusps that are making up those. And again, this fibrous skeleton is electrically isolating the upper chambers of the heart from the lower chambers of the heart. This is going to be important to us as we start talking about how the heart actually functions and what leads to the contraction of the heart. This is going to be important to us. It also provides strength to these and holds those in place, those valves in place. And you can see this with the chordae tendineae and the rest of that there. So what we'll be looking at after this is now going to be a lot more about how does the heart go about beating and what's occurring with that. So that's what we're going to continue on with next. So I will see you next time.